Hi, team. Today I introduce to you the most important of all of the derivative rules, probably the most well-known, most famous, most important. And then you're going to spend the rest of the week practicing. So this is called chain rule. And just to write the rule first, this is for taking derivatives of composite compound functions. So this is not product rule. Those are not being multiplied. That's f of g of x. And the way you do chain rule, if I wanted h prime, you're going to take one derivative at a time, starting on the outside and working your way in. So we're going to take the derivative of our outside function, and you're going to leave the inside alone. And then you go inside and go again. So I'm going to take the derivative of my inside function and leave everything else alone. That's it. I mean, it looks pretty simple when I just write it that way. I think I'll work just a couple examples with you, and then you just need to go dive in and practice and see what happens to you. You really, 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 really should go practice these. Don't think that this is something that, oh, I got because I'm watching her. These mess with your brain. All right, let's go take the derivative of something ridiculous. This raised to the 57th power. So theoretically, you don't need chain rule to do this derivative because you could sit here and multiply out 6x minus 3 57 times. I mean, some of you may not have anything better to do with your day, and I encourage you to find something, but I don't want to do that. So we're going to use chain rule. The hardest part about chain rule is deciding what your outside function is, what your inside function is, etc. So this is our inside function, and it's being raised to the 57th power. So your outside function is this 57 power business. So if I'm going to start with that for taking my derivative, if my outside function is being raised to the 57, then the first derivative rule I'm going to do would be the power rule, where I pull the 57 and subtract 1. And then the most missed part of chain rule is that you try to do too much too fast. You're going to leave the inside alone. So I pulled the 57, subtracted 1, leave everything else alone. Then go inside. So this is our inside function, this highlighted part, and we're going to take that derivative. Well, the derivative of 6x minus 3 is another power rule, but it's clean. It's just 6. The end. That's chain rule. Let's do more. Let's go take the derivative of sine squared. Again, I don't actually need chain rule to do this because I could just do sine times sine and do a product rule, and that would be excelente, and that would work just fine. But I'm here to teach you new things. Remember that this is sine of x squared, so that might help you see your inside and your outside function. Seems to me like my outside function is something that's being squared, and we take those derivatives by pulling a power and subtracting 1, so it's just raised to the first. I'm not going to write that. My inside power is sine, so I take that derivative. Derivative of sine is cosine. The end. All done. More. What if I had the derivative of the sine of x squared? So this one looks similar but is different. This time your outside function is sine. So just like above, the derivative of sine is cosine, but it's the cosine of x squared. You got to leave your insides alone. One derivative at a time. So I differentiated sine, got cosine. Everything else stays the same. Then I go inside my function. My inside is x squared. That derivative is 2x. All right, well, I mean, I can make these up all day long. I do have other things I'd like to do today, but let me show you maybe 2 more. Let me show you something like this, and let's put this in here, and then just like this. So you've been doing derivatives for a little while now. I hope that you're comfortable knowing that this is to the 1/2, and maybe you don't need to write that anymore. Congratulations. If you still do, not a big deal. This guy, you're going to do the same thing. We're going to pull a power. You're going to leave everything else alone, and you're going to subtract 1. And then you're going to go inside. So here's what you've just done. You took care of the 1/2, so I'm going to scribble. So now I have a tangent of 3x where tangent is now my outside function. The derivative of tangent is secant squared. So I have secant squared, leave everything else alone. And uh-oh, what's this? Another function. You have 3x left over. 3x has a derivative. That derivative is 3. So one of the most common questions I would get if I were looking at all of your faces right now is somebody would say to me, how do you know when to use chain rule? And my shocking answer is, it's always chain rule. You're always doing chain rule. You've been doing chain rule since the very beginning. It's just if you had something clean and simple, like just the tangent of x, and you were learning this for the first time, I would say to you, your outside function is tangent, and that derivative is secant squared. You're going to leave the inside alone, times the derivative of what's inside. Well, inside is just an x. The derivative of x is 1. So that's how you know you're done, is when you don't have any more derivatives left to take. So if you always try to do chain rule in your brain, then you're not going to miss, because you should always just keep going back inside and make sure that there's nothing else left to do. All right, I want to show you one more just so I can show you the most common mistake. Let me do something. Let's do secant, because people miss secant a lot, and let's put something exciting inside of secant, like the square root of x. Okay, outside function is secant. I'm sure you're all nodding in agreement. The derivative of secant is secant tangent. Notice how they both get the input. I've got to leave that input alone, so whatever was in there stays in there. Times the derivative of what's inside would be the derivative of x raised to the 1/2, so times a 1/2 x to the negative 1/2. I lied. I want to do one more, but first I want to tell you about the biggest mistake that you'll make as you're practicing these things. I call it going too fast. So if you have the derivative, let's just talk about this guy again. You try to take too many, not you, it might not be you, I don't know who it is. People who do this wrong take too many derivatives at once. And they'll say, oh, I know the derivative of secant is secant tangent. Oh, and the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Can I squeeze it? I sure can. And they do both derivatives at the same time. And I call that moving too fast. You got to slow down, one derivative at a time. Okay. All right, last one I want to do is an e. How about e to the 4x? Something that looks clean and simple. So what you learned before is that the derivative of e to the x is e to the x, and that is still true. I'm not going to change rules on you partway in. The derivative of e to the x is e to the x, but this is not e to the x. This is e to the 4x. So your outside function is e to a power, and the way you differentiate e to any power is just by writing it over again. That's me using this rule here. But then you have to go into the power and take that derivative as well. So this power is 4x. Its derivative is 4. And that'll work. While I'm looking at it, I kind of want to do it a different way too. This is what happens when I don't write notes down before I just start recording and talking to you, is I find other ways I want to work questions. We could think of it that way. And now your outside function is something being fourthed. And we do that by pulling a power and subtracting 1. But then we have to go inside and take the derivative of the inside, and the derivative of the inside is another e to the x. And if I put those together, I get e to the 4x, because you add. That was fun. I like doing that a different way. Okay, that's chain rule. You're going to spend very many days practicing chain rule. It doesn't get harder. You just might get more things to chain, like this guy. This guy had 3 inside you had to go in. And of course, I can mix in product rule and quotient rule inside of them, or a quotient rule that has a chain rule inside of it. So things just start to get really exciting now that you know chain rule. Congratulations. All right, let me know if you need anything.